Yo, yo, yo. It's your boy Max here. We got another physics problem. So for this one, we are given the position of an object, I guess, as a function of time. So what that really means is I have the x and y coordinates for all time. You give me a time, I'll tell you where this thing was. So the first thing we kind of need is we need the displacement between two different times. So we're asking, where did this particle go between t equals 1 second and t equals 5 seconds? So let me start by writing down my vector, r of t. So this r of t is usually used to represent the position of something. So this is really x of t and y of t. And what do we got? We got 4t plus 3, comma, 6t squared minus 7. Okay, so we want the magnitude of the displacement vector from t equals 1 second to t equals 5 seconds. So remember, whenever we're talking about displacement, there's always some kind of initial and final. You have to go from here to here. So first thing I might want to do is I might want to find my position at 1 second. So that will equal 4 times 1 plus 3 is 7. 6 times 1 squared minus 7 is negative 1. Now I can get my r vector at 5. We'll see if I can do this one in my head. 5 times 4 is 20, plus 3 is 23. 6 times t squared, that's 6 times 25, that's 150 minus 7, is that 143? Did I do that right? 6 times 25 minus 7, yes. Okay. So now to get the displacement vector, I'll call it delta r. Remember, this always kind of equals, whenever you're talking about displacement, you always mean some kind of final minus some kind of initial. It's also kind of what this delta means, final minus initial. So I'll get 23 minus 7 is 14. And I'll get 143 minus negative 1 is 144. Okay. And then we want the magnitude of the displacement vector. So, easy enough. I just take the magnitude of this bad boy. That'll get me the square root of 14 squared plus 144 squared. I will write it explicitly. And it equals basically 144. It equals 144.7. So that's the magnitude of our displacement vector. So let's see what happened here. At time t equals 1 second, I was somewhere over here. At time t equals 5 seconds, I am somewhere over here. So here's my displacement vector. And if you look at this, 14, 144, that's approximately what this picture describes as well. And then we are taking the length of this vector. This is 144.7. And that is your answer.